Okay. Once again, we're going to factor out our secant x times tangent x. Okay, so that secant to the fifth drops down to the fourth. And that tangent x, it's only one, so that's really the only one you need. So that becomes secant x tangent x dx. Okay. Now there are no other tangents to convert, so we just go right to the integrating. Okay, so there are other tangent square of x to convert. So we just use substitution and integrate. Okay, so we let u equal secant of x. And we know that our du is secant of x tangent x with respect to x. Okay, so if we go ahead and rewrite that one, you have u to the fourth, secant x tangent x, that's your du. Okay, so that's just u to the fifth over 5, so 1/5 u to the fifth plus c. Plug in our u. That gives us 1/5 secant to the fifth plus c as your final answer. Oh, clean that up a little bit. Okay, so that one's a little bit different because once you factored out the tangent, you didn't have another tangent to worry about, so you had to skip the convert step and go right to the integrating. All right, so any questions on this one? All right. Nope, anyone's still writing? All right. Okay. Now, if you don't have any secant factors and your tangent is now even and positive, then you have to substitute it, and sometimes you'll have to repeat substituting it for secant squared minus 1. So if there is no secant factor and the power of tangent is even and positive, then you want to convert a tangent x squared, tangent squared of x rather, to secant squared of x minus 1, and sometimes you'll have to repeat it. All right, so for example, what if we wanted to evaluate from 0 to pi over 4 tangent 4 of x with respect to x? Okay, so the first thing you're going to do is factor out your tangent squared. Okay, so that gives us from 0 to pi over 4 tangent square of x times tangent square of x with respect to x. Okay, so you're going to convert the other tangent square of x to secant squared of x minus 1. Okay, so you have your integral from 0 to 4. So in tangent squared of x, that becomes secant squared of x minus 1 tangent squared of x. Okay. Now with this one, you're now going to distribute your tangent squared of x. Oh, 0 to pi over 4. Okay, so now you have tangent squared of x, secant squared of x dx minus, well, I guess you can put it all in one instead of making up a whole new integral. I might as well make a whole new integral. And that's the integral from 0 to pi over 4 tangent squared of x dx. Okay, and what they meant by repeat is that if you end up with another even and positive tangent, you now have to replace that with secant squared minus 1. Yeah, so let me see. So even positive exponent. So you're going to repeat replacing secant squared of x minus 1. Okay, so now that's going to give you 0 to pi over 4 tangent squared x secant squared x with respect to x minus the integral from 0 to pi over 4 secant squared x minus 1 with respect to x. Okay. Now for this one, you're going to let u equal secant squared x. I mean tangent squared x. Which means your du is secant squared of x dx. Okay, and for this one,
would u just be tangent of x or tangent squared?
Oh, tangent of x, thank you. Yep, just tangent of x. Okay, and here we know the integral of secant squared x is just tangent x. So if we wanted to, we can go ahead and just separate those, or we can integrate them together. Either one would work. Okay, so this is the integral of u squared, and we have our du. 0 to pi over 4 minus the integral of secant squared, is tangent x, and the integral of -1 is just x. Well, you have your minus there that you distribute to both, so that would be plus 1, or plus x. Yep. Actually, that's still du, so we can't do that just yet. Can't combine them until we convert that back. So pi over 4 oh, I already did that.
Can you move it up a little bit?
Oh, sure. Oh. Here you go.
Thank you.
You're welcome. Okay, so this would just be from 0 to pi over 4. But as soon as we convert that one, we can go ahead and just put them all into 1. Yes?
Would it be minus x still then?
Oh, yep, it will. Thank you. Yep, because I had to convert it back. All right, so this one is just 1/3 u to the third which once you plug in your u is equal to tangent x, that just becomes 1/3 tangent to the third of x, or tangent x to the third. I think I'll put it that way, since we have to plug in values. Minus tangent of x plus x from 0 to power of 4. Alright, so now if we just plug in our power of 4, then our zeros, okay, so we have 1/3 tangent power of 4 cubed minus tangent of power of 4 plus power of 4 minus 1/3 tangent of 0 cubed. Oh, move that up some. Minus tangent of 0 plus 0. I hate to start a whole new sheet, but we're running out of room. See, I'm always regretting all that space I wasted up there. Alright. I'll just go ahead and use another sheet. We recycle, so don't hate me. Alright. Actually, I probably could finish it here. It's only a little bit left, like one. It's 2 lines, but why force it? All right. Anyone still writing? All right. Okay. So we know that tangent of power of 4 is 1, and tangent of 0 is 0. So that leaves us with, and I'll just put that right up there, 1/3. Tangent of power of 4 is 1, so that's 1 to the third, which is just 1. Minus 1 plus power of 4 minus 1/3 times 0 minus 0 plus 0, so that just disappears. Yes?
Is the 1/3 distributed to the whole thing?
Yep, it is. That's why I just, when I broke it up, I just,
No.
I thought
Nope,
it was
where'd it-
distributed to the...
oh, it is.
When you
Well,
integrate it, it's only for the tangent.
yep, for the first one. Actually, it kind of disappears with the 0, so that's probably why I didn't really worry about it, but you're right.
For either of them.
Right. It should just be 1/3 minus 1 plus pi over 4.
Yep, so this one, yep, so this is just 1/3. Yep, you're right. So it just applies to that one.
Right.
Yep. So I'll just add it to that one.
So
So,
in the end here, it should just be like
yeah.
1/3 minus 1 plus pi over 4. Not all that times 1/3.
Yep, so this should be that one. Yep.
Okay. That works.
All right, and actually we don't even need that. So, and that's just 0, so that disappears. So you end up with 1/3 minus 3/3 plus power of 4, which is negative 2/3, so power of 4 minus 2/3, which, plug that into your calculator, you should get 0.119. About that. All right. So any questions on that one? All right. Okay, anyone still writing? All right. Okay, now if the integral of secant, let's say, m of x dx has an odd exponent and no tangent, we're actually going to solve that using integration by parts, which is next class. I didn't want to try to squeeze too much into one. So it's not like we skipped that one, we'll get to that one later. Okay, now if all the other previous ones don't work, so if the previous guidelines do not work, sometimes you have to convert to sine and cosine. Right, so for example, if you wanted to evaluate secant x over tangent square of x dx. Okay, so your tangent squared is even, but it's also negative, so it's not positive, so you can't use that previous method. Okay, but we can also c of x over tangent square root of x dx. We know that secant of x is just 1 over cosine, and our tangent of x is just sine over cosine. Okay, so our 1 over x, or 1 over tangent x, would just be cosine over sine squared flipped. Okay, so this actually becomes, move that up a little bit, the integral of, well, instead of secant x, actually I'll rewrite that first. So you can rewrite it as secant x times 1 over tangent squared. Okay, which makes that the integral of 1 over cosine times sine squared, well, 1 over sine squared cosine squared, if you flip that, cosine squared, I'll say cosine x, over sine squared dx. Okay, and the cosines just cancel out. Okay, so that's the integral of cosine of x sine squared of x dx. Okay, which, looking at this one, if we let u equal, well, I guess we can do it the other way. Yeah, no, we don't even have to do it that way. The easier way to do this, instead of using u substitution, is just have it sine of negative 2x cosine of x dx. So this way, all you have to do, again, is just let u equal sine of x. Means our du equals cosine of x dx. So let me bring that up a little bit. Okay, so that means we have the integral of u to the negative 2 du, which is u to the negative 1 over negative 1 plus c. Okay, so that gives us negative sine of x to the negative 1. Actually looks like sine inverse, which is incorrect. So just to make sure there's no confusion, sine of x to the negative 1 plus c, which is just negative 1 over sine of x if you wanted to rewrite it that way. Okay, which would be your final answer.
Could you write negative cosecant of x?
Yeah, you could, negative cosecant. Either one of those will work. All right, so any questions on that one? Yes. Oh, sure. All right, any other questions? All right, leave that up for a few. All right. Okay, so now we're going to cover trig substitution. Okay, and we're going to use these to evaluate radical integrals. Okay, so for these to work, you have to remember sine squared of theta plus cosine squared of theta equals 1. Okay, which means that cosine squared of theta equals 1 minus sine squared of theta. Okay, which means if you divide all those by cosine, tangent squared of theta plus 1 equals secant squared theta. And also, tangent squared of theta equals secant squared of theta minus 1. Okay, you remember those, it all kind of fall in place. Okay, so let's say, for example, just kind of give a quick insight to where it's headed. If we let u equals a sine of a, or sine of theta. Okay, and we're assuming that a is positive, and it's between negative pi over 2 and pi over 2. Okay, so that means if you have the square root of a squared minus u squared, then that's going to equal the square root of a squared minus a squared sine squared theta. Okay, so if you factor out that a squared, you have the square root of a squared times the square root of 1 minus sine squared theta. Jumping ahead. Okay, square root of a squared is just a. Times the square root, 1 minus sine squared theta is cosine squared theta. Squared and the square root cancel each other out. So you have a cosine theta. Okay, so we can actually rewrite our a squared minus u squared as a cosine theta if we let a equals u sine of theta. U equals a sine of theta. If you notice, cosine is positive between negative pi over 2 and pi over 2, which is why we limited it to that. So cosine of theta is greater than or equal to 0 for negative pi over 2 to pi over 2. Okay, so we're going to kind of revolve an entire new way of solving based on that type of concept. All right, any questions so far? All right. Yep, I'll leave that up for a few. Oop, actually, I might as well go ahead and restart the clock since it'll shut off on its own in about 4 minutes.